Hi everyone, my name is Hernan. I'm doing my PhD in computer science at the University of Chile in Chile. And in this presentation, I will talk about a comparative study of communication patterns across crisis events in social media, specifically on Twitter. First, I would like to introduce some preliminary definitions about crisis that we will use in this presentation. Uh, First of all, an emergency or a crisis is defined as an event that need minimize its adverse consequences, especially in people. We can usually find that crisis and disaster have some differences in terms of the severity and the resources necessary to get back to normal. However, in this presentation, we will use both with the same meaning. Crisis can also define in terms of different hazard dimensions. For example, when we talk about hazard dimension, we refer to who triggers a crisis event. On one hand, a crisis can be generated by humans, and on the other hand, an event can be natural, for example, earthquakes or tornadoes. In addition to these hazard categories, we can also divide them into fine-grained categories. First, we can consider two subcategories for human-induced events. On one hand, intentional events like a shooting or bombings, and accidental events such as crash plane and train derailment. In the case of natural events, we have several subcategories where some of these are geophysical events like earthquake, meteorological events like tornadoes, hydrological, climatological, among others. Furthermore, a crisis can be classified depending on two other dimensions. On one hand, based on the temporal aspect, and on the other hand, based on the geography spread. Considering this dimension, we can describe a crisis event, for example, an earthquake, where an earthquake is a natural event. Its subcategory is a geophysical event, and the temporal development is instantaneous, and the geographic spread is diffuse. Now, after explaining this preliminary definition, I would like to introduce the problem statement that we identified for this research. Disaster are considered social political events because they affect physically and psychologically to people and destroy their properties. And also, they change political laws and redefine cultural identities. Hence, understanding this type of events are crucial because for future similar events, we can decrease vulnerabilities across disaster phases, that is, from the event preparation until recovery phases. In order to extract and understand the impact of these events, the common mechanisms are based on psychometric methods. This is government and emergency relief agency obtain data from affected people based on tens of hundreds interviews and self-reports. Currently, the increase in online conversation has created a major source of real-time data about physical worlds, especially about crisis situations. In fact, this data, published during crisis situation, is almost published in real time. Data is obtained with a low cost, and more important, there is a huge volume of data shared from different locations, languages, and etc. For example, in the case in this example, we can see some messages published in Spanish related to an earthquake, and also in Italian, and also we can find English messages about terrorist attack or bombings. In this sense, experts have recognized that social media represent an important opportunity for emergency relief agency to quickly obtain situation awareness during crisis, helping them improve their preparedness and response. And this happens because they can know what happens in different locations without doing interviews in the place where the event happens. However, there are several challenges that research deal with it. For example, during the 2019, the 2015 Nepal earthquake, this tweet on the left side was published during the event. However, this message for even for human reading is too difficult to understand because contain shortened words, ambiguous abbreviation, British slang, among other things. Hence, natural language processing techniques can fail when they try to automatically represent and extract information from messages. Furthermore, there is a challenge in terms of the messages shared during a crisis event because they include a lot of the irrelevant information. For example, the first message contained the terms hashtag Sandy, but this message is not related to the hurricane or doesn't provide useful information. And the second message on the top uh, also contain the term hashtag Sandy, but in this case, this message is related or directly related to the event. With respect to the related work, and despite this challenge, researchers have identified common and different characteristics based on messages published during crisis. For example, difference in geolocation occurrence in on-top tweaks for two different events like the Oklahoma fire and the Red River flood, and the difficulty to transfer knowledge from two similar events when they try to classify messages, and also textual difference between relevant and irrelevant information or irrelevant messages published during a large collection of events. In more detail, this variation was studied by Oltenio et al. In a large collection of events where they showed that when they analyze related messages, that this is a message for which contain an implicit or explicit mention of the event, they found that these posts were mainly related to emotional support and affected individuals. Furthermore, they apply clustering techniques to find group of crises with similar characteristics using manually tagged features, like in the feature where they find similar event using this clustering or hierarchical clustering techniques. However, some of the problems that we identify in the state of the art related to the crisis characterization is that the studies are mainly developed to determine difference between relevant and irrelevant messages or related and non-related messages. They in some of these studies they consider a small scale number of events or just cases of study to determine some difference in messages, and some of these resolve for relevant and related information when they analyze this type of information. They represent messages just using manually tagged feature instead of automatically computed features. And finally, they don't put much attention toward understanding variation in user communication. That is, what is the difference between different type of event or hazard dimensions. Hence, our research question here and based on the state of the art is, do patterns emerge in social media posts when similar crisis situations unfold in the physical worlds? In this sense, our proposal is perform a comparative analysis of messages related to 41 crisis situations, but in our case, from a textual and linguistic point of view. We believe that this research, in conjunction with the current state of the art in the crisis informatics literature, can contribute to understand in a better way how disasters are based on information published in social network platform and what we can learn about them for future similar events. So, with respect to our methodology, we first consolidate a large-scale dataset of Twitter messages. After that, using this consolidate or this unified dataset, we extract textual features from messages, and finally, we evaluate similarities and difference among hazard dimensions. So, in the first step of this methodology, and after reviewing the state of the art, we identify several works where they use different datasets for different classification tasks. For example, some of them identify if a tweet is informative or not informative, or include information about culture and emotional support, some difference in relevant and non-relevant messages, among other labels. Based on this dataset, we consolidated 6 public available dataset where we create a multilingual collection of messages published during 49 crisis situations. We also unify labels into related and non-related messages based on the proposal proposed by Kerr et al., where a related message is a message for which contain an implicit or explicit mention of the event. Additionally, we enhance with other dimensions. For example, for each of these events or for each of these messages, we include the hazard categories of the event, the temporal development, among other hazard dimensions. And finally, we include the language of the messages based on the Twitter metadata information. Using the full list of messages in our unified dataset, we remove duplicates and discard messages where the metadata were unavailable. Finally, our multilingual dataset contains up 97,000 labeled messages, where most of these, almost 80% of the messages, was or were written in English. Second, and considering that our unified dataset mainly contain English messages, we extract textual features from messages, and as mentioned before, we filter messages based on two main characteristics. First of all, messages just written in English and only related messages. Because we filter only related messages because our goal is to understand what are the patterns in the information directly related to a crisis, instead of comparing, for example, related and non-related messages. Using this filter, we consider for our study 41 crisis events and almost 41,000 related messages. In more detail about this data and these messages, the distribution of the messages by different hazard dimensions are in the following tables, where most of them are event and messages related to natural crisis, and this happen given that the frequency of these events are higher than human-induced disasters. To represent crisis event messages, we extract 54 features from Twitter messages, divided into 3 categories. First, we extract 36 linguistic feature or textual feature using the linguistic inquiry and word count, which allow us to determine if a word belongs to a specific category, for example, positive or negative emotion, or related to family or death terms. Second, we compute 18 entities using the Spacie library, where some of these entities are mention of natural places, organization, or name of persons. And finally, we compute 3 Twitter content features using the Tweet NLP tools, where the idea is to extract, for example, mention of hashtag, user accounts, or links to website. And finally, each of these features is represented at its relative frequency of occurrence in the event, and then we apply RSync transformation for each of these features. For example, in this case, we group a crisis into hazard categories, that is between human-induced and natural events, and also we group them into hazard subcategory, for example, accidental, intentional, hydrological, among other. Our idea here is to compare this hazard dimension and find the feature with significant mean value difference. That is, we compare human-induced and natural events, and we compare accidental and intentional events, and we find this feature with significant mean value difference. Using this feature with significant mean value difference, for each pair of this crisis group, and using this feature with significant mean value difference, we apply clustering techniques to discover common linguistic patterns between hazard categories and subcategories. In honor of the time, I will show you just an example of this analysis given we did multiplex combination among hazard dimensions. In this case, for human-induced and natural events, our goal here is using this set of features is to separate and group events in their corresponding categories, in this case human-induced and natural events. The image represents two clusters where the vertical black line divides the events into these two hazard categories by using this set of features which contain significant mean value difference. To evaluate the quality of this cluster, we consider that an event has been correctly assigned to a cluster if the cluster that contains the event also contains other event of the same hazard category or the same subcategory depending on the evaluation. That is, for example, if this cluster just contains human-induced events or natural events, we expect that all of the clusters contain the same type of event. In this case, for example, the right cluster mainly contain natural events, and we expect that this cluster contain in the majority this type of events. To quantify this, we compute traditional classification metrics like accuracy, precision, recall, and F1 score. With respect to our recent crisis evaluation, on average, we correctly assign an event with an accuracy of the 75%. And in more detail, our best result were when we evaluate hydrological and geophysical event, and our worst result were when we evaluated hydrological and meteorological event. We believe that this last result could be because we found just a small number of features with significant mean value difference, and also we believe that this result could be because the event actually seems similar based on social media messages. With respect to the discussion, we compare a result for human-induced and natural event with other domains. In this case with Wikipedia articles and psychological study. In the case of Wikipedia articles, we found that articles and tweets seem similar in terms of emotional reaction, mainly related to negative emotion. Also, we identified that terms related to cognitive processes and social processes were similar in both platforms. In the case of the psychology studies in affected people, we also found similarities in emotional reaction, given that people evoke higher levels of negative effect when an event is triggered by others. Also, we found a similar reaction in how people try to understand the reason of the event when this is a human-induced event. And this can be explained because we found high values in the use of terms related to insight, like a think, know, and consider, and perceptual processes like a see, hear, and feel. Finally, with respect to the conclusion, we found that crisis event related messages can be represented using a small set of features, in this case the linguistic and textual feature, and this feature can exhibit different and similarities amongst events related to their hazard dimension, like the hazard categories and the hazard subcategories, and we believe that our result can complement current research. For example, using classification method in the state of the art to filter irrelevant information, we could automatically group related messages into one hazard category or subcategory, and this could be improved situational awareness based on what we can expect from similar events based on their hazard categories or hazard subcategories. For future research, we want to expand our crisis characterization, where we want to analyze other hazard dimensions like the temporal development and the geographic spread of the event. We want to add more and more event messages, and event and messages. And more important is we want to include messages in other languages to perform a multilingual analysis. That is, compare, for example, one type of one hazard categories in English and Spanish, and try to find similarities in the languages and in the textual features. So this was my presentation. Thank you.